The following question reads that horizontal metal bar PQ of length 50 cm is hinged at P. The diagram shows the metal bar viewed from the above. So it's hinged at P. So it's this is the pivot, and the two forces acting and on the metal bar: 16 Newton force at a 30-degree angle, at a 5 Newton force at a 90-degree angle, and the distance is given from the pivot. This is the pivot. So two forces are acting, and this is described over here. So what is the total momentum about P due to the two forces? So we need to find the total moment about P due to the two forces. So let's try and calculate the moment. Now the moment, this is the first force, 5 Newton force, and it's going to create a clockwise moment. As you can see, it's at 90 degrees, it's perpendicular. So it's going to swing this force over here. If this force was only present, then this ruler would swing in this direction in a clockwise fashion. And the moment is going to be perpendicular force, the perpendicular distance from the force. It's going to be 5 Newton force into 50, so it's going to be 50 centimeters, and 50 centimeters should be calculated because as you can see, all the moments in your answers are given in Newton into meters. So we need to convert 50 centimeters into meters. So it's going to be 50 divided by 100 into 5. So this would be equal to this would be 1 by 2, and your answer would be 5 divided by 2. So it's going to come out to be equal to 2.5 Newton meters. But remember, this is clockwise. Now for this other force, we first need to find the perpendicular force that is acting at this point from the pivot. So this is the ruler, and we need to find the perpendicular force component, perpendicular component of this force. So what we are going to do is that I've constructed this triangle now, and I'm going to try and find the perpendicular component of this particular force, 16 Newton force. So this angle over here is 60 degrees. Remember, this is going to be 90 degrees. We're finding the perpendicular force. So it's 60 degrees. So the component of the force, the perpendicular force, is going to be this would be the hypotenuse. It's 16 newtons. The angle is 60, so it's going to be, if you do cos of 60, is going to be the opposite side, which is going to be, let's call this F. So it's going to be the opposite side divided by the 16 Newton force. So cos of 60 adjacent side divided by the hypotenuse. So F divided by 16 newtons. So it's going to be F would come out to be 16 cos of 60, and we need to multiply it by the perpendicular distance. So I'm going to multiply it by D, which is going to be this distance over here. So perpendicular force into the distance from the pivot, which is 50 centimeters, which should be converted into meters. So it's basically 50 divided by 100. And the answer for this comes out to be 4 Newton meters. So, but remember, this is going to move the ruler in an anti-clockwise fashion. So you have an anti-clockwise moment, which is 4 newtons, and you have clockwise moment, which is 2.5 Newton meters. So the net moment, if you add the two moments together, they're going to get subtracted. Clockwise minus anti-clockwise minus clockwise, so it's going to be 4 minus 2.5, which is going to give you 1.5 Newton meters. So it's 4 Newton meters, which is your anti-clockwise moment, minus 2.5 Newton meters, which is your clockwise moment. So if you subtract the two together, they're going to get subtracted because they're acting in opposite directions. So your answer is going to be 1.5 Newton meters.